minus 3 equals 1. So we can combine these. Remember our compression rules, or our condensing and like expanding rules that we went over last week? So we can condense these. Remember that like when you see a plus sign here, you can condense them and multiply them if they have the same base, which these do. These have a base of 10. So I can multiply them, and I can say, okay, I'm going to have log of x times x minus 3 equals 1. So I combine them and I multiply them. So from here, we can distribute the x in, and we'll have log of x squared minus 3x equals 1. And then we can rewrite it into exponential form, because remember it has a base 10, so we can rewrite it as 10 to the first power equals x squared minus 3x. So now our log is gone, and you can see that if we move everything to one side, we'll have a quadratic formula, a quadratic equation. So I'll move the 10 over, and I get 0 equals x squared minus 3x minus 10. So from here, I can factor it to find the solution. So I'm going to factor it. You can use the snowflake if you like the snowflake. But I need two numbers that multiply to 10 and add to 3, which are going to be 5 and 3. And then I want a negative 3. So it's a negative 5 and a positive 2. So these are going to provide my solution. So I will set each one of them equal to 0. And solve them. So I add 5 to both sides, and I get x equals 5. Subtract 3, and I get x equals negative 3. So here are my two solutions, but I need to check them to make sure that I don't get a negative number. So, because we can't take like the log of a negative basically. So I'm going to check them. And we want to make sure that they like work out. So let's check the 5. So I'm going to plug the 5 in. So I'll have log of 5 plus log of 5 minus 3 equals 1. And so that's going to get me log of 5 plus log of 2 equals 1. And then I can compress them to multiplication again. So 5 times 2 equals 1, and then remember we can rewrite it, so we get 10 to the first power equals 5 times 2, which is 10, so that one works out. So x equals 5 is fine, but look at what happens whenever we get, whenever we check x equals negative 3. It should not be 3, it should be 2. Sorry about that. Over here when I was 5 times 3 is 15. This should be a 2 right here, because 5 times 2 is 10. So this should be a 2, a 2, a 2, a 2. So it's actually x equals negative 2. So we're going to check negative 2. Sorry about that. So I get log of negative 2 plus log of negative 2 minus 3 equals 1. So we don't even have to simplify it, because the domain of log functions only consists of positive numbers. So like you can't take the log of negative 2. So that's what I mean when I was saying like you don't want it to be negative. So our only answer here would be the 5. That would work. The 2 would not work. Okay, let's do another one. We have like one more, maybe 2. Let's see. Here we go. Natural log of x minus 3 equals the natural log of 7x minus 23 minus the natural log of x plus 1. So they all have the same base. They have the same base e. So we're going to start by condensing the ones on the left. The right, so the minus sign here tells us I can condense them to a division problem. So I get natural log of x minus 3 equals natural log of 7x minus 23 over x plus 1. And so I've condensed it here. And so now since they have the same bases, they both have a base e, I can set them equal to each other. And I can set x minus 3 equal to 7x minus 23 over x plus 1. And so from here, it's just an algebra problem where we need to solve for x. So I'm going to solve for x. I'm going to start by multiplying both sides by x plus 1 so I can cancel out that denominator. That cancels, that cancels. And I'm left with x plus 1 times x minus 3 equals 7x minus 23. So we're going to keep simplifying. We're going to end up with a quadratic, but we're going to start by distributing. So FOIL, distributive property, whatever you want to call it. X times x is x squared. X times negative 3 is negative 3x. 1 times x is x. And then 1 times negative 3 is negative 3. And then I'm going to move everything to the left side so that it's all on one side. I'll move it one at a time. Ooh, I didn't combine these like terms. Sorry, I feel like I'm just like messing up today. So I'm going to combine those now here. I'm going to move the 23 over. And I get this. Okay, so from here we're going to factor it equals 0 because there's nothing left. So I'm going to come over here and write it. And we need to factor it just like we did the other one so that we can get the solution. So we need two numbers to multiply to 20, add to 9, and it's going to be 5 and 4. And they're both going to be negative because I need a negative 9. So then I will set them equal to 0. And I get x equals 5 and x equals 4. But we need to check them and make sure that we don't get a negative. So we're going to plug them back in, and you could probably just like plug them back in your head almost and just make sure you don't get a negative, but we'll do it. We'll write it out. So like for the first one, when I check that one, I get natural log of 5 minus 3 equals natural log of 7 times 5 minus 23 minus natural log of 5 plus 1. So this is going to give me a positive 2. This is going to give me 35 minus 23, which is a positive number. And this is going to give me 5 plus 5, which is a positive number. So that one checks out. We're okay. They're all positive numbers. Let's check the 4. I'm going to have natural log of 4 minus 3 equals natural log of 7 times 4 minus 23 minus natural log of 4 plus 1. 4 minus 3 gives me a 1. That's positive. Over here, I have 7 times 4 is 28 minus 23. That's a positive. And 4 plus 1 is a positive. So they both check out on this one. So my solution set is both 4 and 5. Because they both work out. Great. And I think that brings us to the end of 4.4.